Now, can I really use z-scores? Because those are relative values and the scales are different. So let's take a look at how data behaves when we shift and we scale it. Now here's an applet on GeoGebra that takes a look at the impact of shifting data and also scaling data. So right now I'm just going to look at shifting data. This data, believe it or not, is actually shifted right now, so I'm going to set it back to 0. What do you notice as I shifted it back to the original? Did the shape change? No, it didn't. What did change was the actual mean moved up as I put it back, and the median moves, and the Q1 and the Q3 move, and you could argue your min and your max of your data move. So the shape stays the same as it moves. So the measures of position are the only things that change. The measures of spread, this box didn't get any wider or smaller. So those values stayed the same. That includes the range, the interquartile range, and the standard deviation. So you can shift data all you want, and all you are affecting are things like mean, median, the quartiles, and min and max. You are not affecting the range, the interquartile range, or the standard deviation. Now let's take a look at scaling, which is when we multiply or divide all values by the same constant. Here I'm just doing multiplication, and I'm multiplying by a. So if I increase this, you're going to see that basically not only am I increasing the values for mean and median, so originally when I had 1 as my value right here, that was about 10. And when I change it all the way to 2, it's about 20. So all the values, including the spread, the standard deviation, the IQR, the Q1, the Q3, all of the values in the data are multiplied by that factor. The only thing that doesn't change is the z-score because it's a relative value. So if something is 1 standard deviation when the multiplier is 1, it's still 1 standard deviation away when the multiplier is 5.